Welcome, ladies and gentlemen, to today's lesson, dealing with our kind of the end of our unit here, kind of the final part, and that's proving that two shapes are congruent. So we've been listing, like the transformations that carry one figure onto another, but here we're actually being very formal in how we write up our answer, which is why you should have picked up one of these little half sheets here, and we're trying to prove that this shape here is congruent to this one. Well, first things first, you need to figure out the series of transformations that will carry 1 onto B. So go ahead and pause the video or just take a moment to figure out what transformations carry 1 onto B. Hopefully you're able to figure out that if you were to rotate this 180 degrees, it would look like this. And then if you reflect over this line here, which happens to be y equals negative 1.5, it'll flip over and it'll land on B. So we got those transformations. We got rotate 180 degrees and then reflect over y equals negative 1.5. Okay, so that's the list of transformations, and that is right. But if we're going to prove these two shapes are congruent, we have to use some precise language and precise sentencing here. This is good information. You're going to use this, but we're going to kind of make it more formal. And it's going to look like this. In our little proof, we're going to write out 2 sentences, with like capital letters and verbs and a period at the end. There's going to be 2 whole sentences. And in the first one, we're going to list out the transformations that carry 1 onto B. So we do that. Just rotate 180 degrees, reflect over y equals negative 1. And then in our second sentence, we're going to state that those 2 transformations are rigid transformations. And since they're rigid transformations, which preserve side lengths and angle measures, and it keeps everything congruent, it preserves congruence, these 2 shapes have to be congruent. So that's what our 2 sentences are. And if you're looking at your paper, it already has that typed out for you. So here's how it works. First sentence here, rotating figure 1 180 degrees about the origin, and then reflecting over y equals negative 1.5 maps figure 1 onto figure B. Yes, that is your first sentence. It's a long sentence. It's got a lot of words in it, but it's really just saying the whole thing. Here's how you go from 1 to B, but in a very mathematical sounding sort of way. And I wanted to point out that mapping is actually like a verb. It's a mathematical term when something maps onto another. So that's an excellent one to have in there. The second sentence here is saying that, well, we already listed the transformations, and they're rigid transformations, and so these figures have to be congruent. So it's saying, since rotations and reflections are rigid transformations, remember, rigid means it keeps the shape congruent. Figure 1 is congruent to figure B. So everything got mapped on from 1, got mapped onto B. We did rigid transformations, and that proves that the 2 shapes are congruent. And so this is what your answers are going to look like on your paper. It's going to take 2 whole sentences, one saying what the transformations are that map one onto another, and the second sentence saying those are rigid transformations, and so the shapes are congruent. And so let's dive onto your actual assignment. It starts with the same picture, but now you need to prove that figure 1 is congruent to figure C. So first up, figure out what the transformations are. You can jot some notes for yourself, and then we'll write out the proof. So pause the video, take a few moments to figure out the transformations that carry 1 onto C. Hopefully you caught on that if you reflect this over the y-axis, it's going to be here, and then you translate left 1 unit. So those are my transformations. So now you need to write out the proof. So go back to that little note paper, see if you can write out a proof looking like this. It's 2 sentences. How do you go from 1 to C? Listing the transformations, and then state that those are rigid and so they're congruent. So pause the video, see if you can get it all written out. All right, let's have you check and see how you did. Did you mention reflecting figure 1 over the x-axis and translating left 1 unit maps figure 1 onto figure C. That should be your first sentence saying the transformations that carry one into another. And then your second sentence saying reflections and translations are rigid transformations. Thus, figure 1 and figure C are congruent. I phrased this one a little bit differently. I didn't say since these are rigid transformations, they're congruent. I said these are rigid transformations, thus they're congruent. It just, you can put some variation into your answers, but it's the same idea there. So hopefully you're able to write out your proof just like that. If it didn't look just like this, you're not being precise enough or you're cutting some corners. Please use this exact sort of language. Get used to writing like this because this is very mathematical sounding. It's a proof, and that's what proofs are. We're going to do one more, and this is actually a disproof. A disproof. We're disproving that two shapes are congruent. And this is on the back. And this is going from this triangle here to this one, which these are not the same triangle. This one is one taller than this one. But if we were to just reflect over here, reflect over our y-axis, we get P, we get R, and then we get Q up here. And it's a little bit taller than the original one. And I know that, and you know that, and now we're just going to write out the disproof that these two are congruent. And so it's going to be really similar. I'm going to just state the transformation that carries PRQ on top of STU, but then note that Q doesn't map onto U. So here's how it goes. So I'm going to write out reflecting figure, I just write out triangle, sorry. Triangle PRQ over the y-axis. I'm going to put, now I got that, it maps P and R, sorry, I'm going to just do a segment. It maps segment PR onto ST, but Q does not map onto U. So this sentence is really similar to ones we've been dealing with, right? You reflect over and it maps certain parts onto others. But Q does not map onto U, and that's showing that it's not congruent because we did a rigid transformation, and rigid transformations keep things the same size and the same shape. And so that's my second sentence is mentioning that reflections are rigid transformations and it didn't work. And so they're not congruent. So that's what I'm going to write. Reflections are rigid transformations. Are rigid transformations. And triangle PRQ did not map onto triangle STQ. Thus, triangle PRQ is not congruent to triangle STU. I don't know why I put a Q here. This should be a U. My bad. U. There we go. STU. All right, so that's how a disproof works, and that's actually level 4, kind of taking things to the next level. To get level 3, you have to be able to do proofs, and if you want level 4, you're going to be able to do disproofs. So that's kind of how they're a little bit different. Some things map, some things don't. So there you go. Good luck on your assignment. It's a lot of kind of the similar things we've been doing, but it's being more formal and putting things into actual sentences. So good luck, ask questions, get it done.